The first module we'll take for here is a point charge of Q, where it is given as minus 0.3 microcoulombs and M is given as mass, that is 3 into 10 raised to minus 6 kg, is moving through the field. Electric field intensity is given as 30 in the direction of AZ, volts per meter. Using the equation of force on a charge particle by the electrons, where the electric field intensity and Newton's laws, we have to consider of that and develop a differential equation and solve them subject to the initial conditions. What the condition is given as t is going to be equals to 0 and velocity is given as 3 into 10 raised to 5 ax in the ax direction meter per second at the origin, and one more thing is given as time is given as 3 microseconds. Based on this given data, we have to find what is the position of the point, that is P of xyz of a charge, and also about the velocity, the kinetic energy of the charge. These all things we have to calculate. The first will go with the position where it is located. The position of the charge, it's given by, they only given, that is P of xyz, it is of. Then what is the force and our what is the given data for us, it is of in terms of electric field intensity. Okay, for that reason we have to take the equation such that it should we have many equations where force is located with the distance, our line integrals, surface integral, all the equations, but the equation should be in between of force and also of the electric field intensity. So the force exerted on a charge by E is given by, we know this equation, that is F is going to be equals to Q into E. Then by using of the Newton's second law, from basics we know about what is the Newton's laws, right? Based on the Newton's second law, that is F is going to be equals to what? We know the equation M into A. That is going to be equals to M dV, voltage velocity divided by dt in terms of differential equation. That is nothing but I can write here as d square z divided by dt square. Then if I go with equating of both the equation here, then I can write it as, here it is M is there, okay, don't skip off that. M d square z divided by dt square is going to be equals to Q dot E. There we know the Q charge, how much is there, and also we know the electric field intensity. That you substitute here, then we're getting as minus 0.3 into 10 raised to minus 6 into 30 in terms of AZ direction, where it is going for that reason. Then the initial velocity is going to be a constant and it is in x direction. So we know not required of a force, no force is applied in that direction. Therefore, the equation what I can change here is of d square of z divided by dt square is going to be q times E divided by M. This is taken here, this side. That's it. Then integrating the equation for this, so that I can get with the what is the z location I can find out for that reason. Therefore, dz by dt it's going to be equals to vz, that is nothing but q e, this is a constant for that reason, divided by m. With respect to t I am going to be integrating, for that reason t integration of 1 is t plus a constant value, that is you will be getting as k1. You can write c1 anything, here it is taken as k1, where k1 is a constant of integration. We have to find what is the k value now. At taking the condition here is that at t is going to be 0, initial velocity in the z direction is going to be a 0. Then the equation is going to be what? Z is, its value is going to be 0. That is the whole t is going, if it is 0 means you will be getting as k1. K1 is going to be what? Now it is going to be a 0 only. Then the equation what's taken here, it is of, if it k is 1 is 0, then v is going to be equals to dz divided by dt, that is nothing but q e divided by m into t will be left in. This will go off now. Then what we want the z. For that reason again integrating the equation one more time. Therefore, if I integrate the one more time, I will be getting as, already t is there here, sorry, here t is there. If I integrate this once again, you will be getting as t square by 2. For that reason t square by 2, z is going to be equals to qe divided by m, t square by 2 plus the constant is going to be k2. Then what we have to do? We have to find out what is K2. What is K2? At the condition is we are going to take T at 0. Therefore, again substitute Z again is going to be 0 at the origin. For that reason, the Z value is also 0. T is 0. Therefore, K2 is also going to be 0. Therefore, the equation is going to be now Z is going to be QE divided by 2M T square. We know all the values here. Just you have to substitute those. Substitute for Q, E and also M. And T also given for us, that is 3 where it is given, that is 3 microseconds that you have to substitute here. Then you will be getting the value for Z as minus 0.135 meters. The distance we are calculating for that reason. Then we got our Z value now. Then we want X and Y direction. Let us consider the initial constant velocity in X direction. The charge, what it is going to be, attains at X coordinate. X is going to be equals to V into T. That is going, you have to substitute for V and also with the T. Then repeating as 0.9 meters. Then hence at T is 3 microseconds, the position of the charge is given by P of XYZ is going to be equals to X is 0.9, Y is going to be 0 in this case. Then Z is of minus 0.135 meters. This is what we got the position of the charge where it is located. Then we have to find out what is the velocity of this. At time is of 3 microseconds. For that reason, what we know, velocity equation is of QE divided by M into T. In the previously we find out the same thing. You go with substituting here, you will be getting V as minus 9 into 10 raised to 4 in the direction of Z meter per second. Actual velocity what we got is different, and the velocity what we now we are obtaining at 3 seconds of delay, it is different. Then we want actual velocity. So the actual velocity of the charge can be obtained by including the initial constant velocity in the X direction. Therefore, we are going for both velocities, that is V is going to be now X direction and also with the AZ direction. Therefore, 3 into 10 raised to 5 AX minus 9 into 10 raised to 4 AZ meter per second. This is what the velocity. Then kinetic energy of the charge, the Ke is going to be 1 by 2 m v square, velocity square, mod of velocity square. Therefore, we got the velocity here, the total velocity, right? For this, we have to take the mod. Therefore, substitute for m value here. Then v mod of v is going to be square root of 3 into 10 raised to 5 square, then plus minus 9 into 10 raised to 4 square. That square root of the square is going to be, go with the calculation here. Then repeating as K is going to be 1.4715 into 10 raised to minus 5 joules. This is how you should carry out the given problem where it is as per position, velocity and also about the kinetic energy. Just remember the equations where it is used, how to find the x, y, z values, and about the kinetic energy equations also. These are all basics. When we are going to solve with the theory part, we have not taken too much concentration of these equations, but you should know the basic equations of each and everything where you learnt in a physics subject. Next is of a charge of Q is given, that is 5 into 10 raised to minus 18 coulombs, is moving through a uniform magnetic field of B is given as minus 0.4 AX plus 0.2 AY minus 0.1 AZ Tesla, and with a velocity of V is going to be given as 2AX minus 3AY plus 6 AZ into 10 raised to 5 meter per second at the origin with the time as given as 0. Based on this given data, the first what you have to find is what is the electric field present at T is going to be 0 if the net force on the electron is 0. Force is going to be 0. Then if the electric field intensity is in the AX direction entirely, find what is EX if F total is of 2 piconano. What is this? We have to go with. This is what are the given data that you have to take written here. Then by definition we know this equation, that is F is equals to Q E plus V cross with B. This equation we know. Therefore, at T is going to be 0. The force is in the first condition is also going to be 0. For that reason, F is also 0. The F is 0 means we can substitute for. We don't know what is E. We know V and also we know what is B value. That you have to substitute in the equation now. Then multiply with the whole E plus the substitute for E value of V and also with the B. Now observe here what is E is going to be now. The whole consideration towards this side, the whole will be getting as minus value, right? That here taken as it is. Then this it is a crossed. We know how to solve for the cross product. That we have to go with the cross product of ax, ay, az and substitute for 2 minus 3, 6, then minus 0.4 plus 0.2 minus 0.1 in the determinant and find out what is the value you will be getting. Then go on solving for this. You will be getting E as 0.9 into ax plus 2.2 ay plus 0.8 az into 10 raised to 5 volts per meter you will be getting up. Next, we asked for in the x direction what is the electric field intensity. That is E is going to be now Ex into Ax. Means F is going to be equals to what? Q E plus V. It's a cross. Make this correction here. It's a cross with B. Right? What is E is now? We want Ax and with the Ax direction. Ex in Ax direction. For that reason, here written E in terms of Ax, Ex into Ax. Okay. Then we know this is the determinant value. Previously we calculated of that part, that you have to substitute directly here. Then F is going to be you will be getting as 5 into 10 raised to minus 18 Ex multiplied here of this part, then minus Ex of this taken a common, Ex minus 90,000 into Ax minus 22,000 Ay minus 80,000 Az you will be getting out. Then but force at this point is of what now? The problem it is given, it is of 2. That is 2 into pico, that is 10 raised to minus 12 newtons. Hence finding the magnitude on both sides if we are going for, then it's going to be 2 into 10 raised to minus 12, that is going to be equals to, here it is a varying function. For that reason take the magnitude of this whole part. This you will be considering as a 1 unit. For that reason Ex minus 90,000 square plus minus 22,000 square plus minus 80,000 square. Then go with the calculation. If we want what is our Ex, that you have to keep here. Then go on solving for this. You will be getting for Ex minus 90,000 square is going to be equals to 1.052 into 10 raised to 11. And then take the square root on both sides. Then go calculation of your Ex. You will be getting as based on this value 414.355 into 10 raised to minus 10 raised to 3 volts per meter. Or else in the negative way, it's going to be in the opposite direction. It is of 234.3955 volts per meter. This is how you will be getting of the values. Next problem is of a current element of 2 meter in length lies in the y direction, y axis, centered at the origin. Then the current is 5 amps in the y direction. If it experiences a force of 1.5 Ax plus Az by 2 square root of 2 newtons due to uniform field, that is B, we have to find what is the B value now. Force is going to be exerting on a straight current elements. Observe here current element in the uniform magnetic field. Therefore, the equation for force is going to be what now? I L into B. Right? Force is of what? Substitute that force here. Then it is going to be equals to I is of, they given for us, it is of 5 amps. Then L is of what? In the direction of 2 meters. They are telling that it is AY direction. For that reason 2 into AY. It is crossed with B. We don't know what is the B value. For that reason writing the equation in terms of all the elements. That is BX, B in AX plus BY AY plus BZ AZ. Now we want, we know the cross product again. Use of cross product. Observe here, we don't, for bx by bz we don't know of those values. For it is written as it is, but in this case it is only, it is consisting of ay value only. For that reason ax and az value are going to be 0. Substitute for a y only as 10. Then 1.5 by root 2 you'll be getting as 1.0606 ax plus az. Then go for your determinant. It's a simple determinant. You'll be getting as 10 bz into ax minus 10 bx az. Then comparing the coefficient values in terms of ax with ax. Therefore 10 into bz is going to be equals to what now? 1.0606. Then for ay az it's going to be 10b, it's a z, is 10 bx. Here you will be getting as bz value, here you will be getting as bx value. You will be getting as bx as minus 0.10606 and bz as 0.10606 teslas and teslas. Therefore in this case we didn't got ay direction, means it will be a 0 value only. For the reason therefore the uniform magnetic field is going to be, B is going to be equals to now, I can write it as here, taking 0.1060 as common here, 0. That value, and remaining is of what? Minus ax plus az in terms of a tesla. This is about a magnetic field. Then the next problem is of, this is simple, like this problem will be for 4 marks. Next problem is a rectangular loop of wire in a free space. Join the point A is in A point is 101 and B is 301 to C, that is 304 to D 104. All to the, again it's going for the A. Then the wire carries a current of 6 milliamps flowing in AZ direction from B to C. Then a filamentary current of 15 amps flows along the entire Z axis in the AZ direction. Based on this, we have to find what is the force on sides BC, AB, and also force on a total on the loop. This is the construction where the rectangular loop of a wire, it is placed in the XZ plane. How you are taking here, it is going depends. Okay, XZ plane, which is clear from the coordinates that it is points are from A to D. Therefore A, B, C, D it's taken. The filamentary current flows in the Z axis. Observe here, this is I is going to 15 amps, how it is flowing. This is the construction. First, the magnetic field produced by the straight filament, we know the equation, that is H is going to be I divided by 2 pi x into AY, amperes per meter. Then hence the magnetic flux density is given, that is B is going to be mu terms of H. Mu is going to be mu naught into mu r, that is going to H. The condition is given, it is for placed in the free space only. For that reason you will be getting mu r is going to be equals to 1. Therefore B is going to be mu naught times H, that you have to substitute here. Mu naught value is of 4 pi into 10 raised to minus 7 into H value is given as 15 divided by, substituting here I is 15 divided by 2 pi into x into ay. That's you have to go for it, go for simplification. Then we'll be getting as 3 into 10 raised to minus 6 divided by ax into ay Tesla. Then hence the force is on BC, means at this we want. Therefore side is BC is given by FBC is going to be minus I integral closed integration B cross DL. While we are choosing the equations, once you go through the theory part, which equation is suitable so that I can use of that. Based on that, you have to take the equation here. Then you will be getting as minus 6 into 10 raised to minus 3 integration, where it is varying from, observe here, 1 to in the z direction 1 to 4. 1 to 4, then substitute for your B cross DL, it is in AZ direction, for it is in DZ into AZ you will be getting here. We know the what is the value of B in the previously, that you have to substitute here. Then but along the side BC, X is of what value? It is of 3. Observe here, X is value is of 3. Therefore, X value we can substitute here as 3. Then go with the solving for this. Observe here, AY cross with AZ you will be getting as AX based on the basic rules. In the first module we learned, that is here it is mentioned already. Therefore, I can, what is the remaining is of integration, Z is varying from 1 to 4, dz divided by 3 plus AX you will be getting off. Therefore, go in solving of this, you will be getting as minus 18 into 10 raised to minus 9, Z integration with one value right here. The for reason Z divided by 3, limit varying from 1 to 4 into AX. Then apply the limit here, then you will be getting as minus 18 into 10 raised to minus 9 AX. That I can write here as minus 18 AX nano newtons. Then we want the force at side of AB, where it is in this direction. Therefore, FAB is going to be same equation you have to go with, but where is X is varying, that you have to change here. That is X is varying from 1 to 3. For that reason, change the integration, only integration changes where X is varying from 1 to 3 and remaining as it is, B into DL. Then substitute for same condition what we taken the previously, same thing, procedure is same. Go on substituting here. Observe here, here you will be getting as 1 by X. X you should not substitute here. We want the in the X direction only, we already taken the integration. For that reason, 1 by X integration is going to be ln X. Then go on calculation here, they will be getting as 19.775 into 10 raised to minus 9 AZ, or else you can write as 19.775 AZ into 10 raised to minus nano newtons. This is what we got for the force at AB and also at BC. Then what we want? We want a whole, the total. For that reason, the force exerted on side DA we will be calculating now at this point. At CD, then I minus I integration B into cross DL, that's going to be at the CD of this point, where X is varying from 3 to 1, then remaining as it is. Again go for the same steps it will be following now. Then what it is indicating, that we have to find, if I want to the total force what is going to be for each side, I have to find out what is the force. Then what at last I should be adding all the 4. For that reason, across CD we have to calculate and across DA also you have to calculate. The procedure will be remaining same for a whole what we taken the previously. At force at CD you will be getting as minus 19.775 AZ. At DA you will be getting as 54 AX nano newtons. Now lastly, F total is going to be, you should go with the all sides of the force, that is FAB, FBC plus FCD, then plus FDA. Then go in adding of these all, then you will bring as 36 AX nano newtons. This is how you should go with the each side of the, how you are going to be finding the force. Then this problem you can do as assignment. It is similar to the previous one only. Just integrating each and every element you should go for that is. Then next problem it is given, that is a rectangular loop carrying a current of I2 is placed parallel to the infinitely long filamentary wire carrying a current of I1. Then a distance between the current carrying wire and the nearer side of the rectangular loop is taken as rho naught. The width of the rectangular loop is A and height is B. Then determine a force experienced by the loop. What is the force is going to be experienced by this element? This is how a construction is going for a rectangular loop with a width A, width is A, then height is B, placed parallel to the infinitely long conductor. This is a conductor if I am going to be considering, and this is a rectangular loop placed. What we want? We want the force experienced by this loop. Due to infinitely long wire, a magnetic flux density is going to be, that is B1 is going to be, here it is taken as mu naught I1 divided by 2 pi rho naught A pi. This is the standard equation. Tesla. Then force exerted by the sides. Each side we want. At AB is given by the current what is flowing in this case is of I2. That's F1 is going to be minus I2 integration B1 cross with DL2, that is going to be minus I2. Observe here at this case our integration Z is varying from 0 to B, the distance height what it's having. Then substitute for B and also with the DL. Here DL is going to be what? DZ into AZ only. Then what is the varying factor is of only DZ is varying, so we'll be adding as minus mu naught I1 I2 B divided by 2 pi rho naught into A rho newtons. Observe here how it is changing. Everything is mentioning here. Just you go through that. Then it is what we got at side BC AB. Then in the same way we have to find it at side BC also. Therefore F2 is here it is taken as F2, that is going to be minus I2 integration B1 cross with DL2. Observe integration is varying in this case is of rho is rho naught to rho naught plus A. Then substitute for B and also with the DL. Here is d rho into A rho in the BC direction. Then you will be getting, go on solving for this, you will be getting as plus mu naught I1 I2 divided by 2 pi into ln 1 by rho naught plus A minus ln 1 by rho naught into AZ newtons. In the same way, go with the calculation force exerting on CD and also with the DA also. Observe here, going on substituting of this simple maths, you can do of this. Then what we want, the total force is going to be, F is going to be equals to F1 plus F2 plus F3 plus F4. Then go on adding of all, you will be getting as F is going to be mu naught I1 I2 B divided by 2 pi rho naught into A rho plus mu naught I1 I2 B divided by 2 pi rho naught plus A into A rho. Then simplify, go with the simplifying, F is going to be minus mu naught I1 I2 B divided by 2 pi, remaining is of 1 by rho naught plus A minus 1 by rho naught into the whole into A rho. Therefore, I can this minus sign taken multiplied here. Then we'll be getting as F is going to be mu naught L2. This is I1 I2. This is I1 I2 B divided by 2 pi 1 by rho naught minus 1 by rho naught plus A. That minus A rho it's taken here into in terms of newtons. This indicates that the force of attraction and infinitely long wire tries to attract the rectangular loop towards it. Means if the loop what is there, it is attracting towards the conductor. This is what the problem. Next problem is of a two wires carrying a current in the same direction of 3 amps and 6 amps are placed with their axis 5 cm apart. Free space permeability is given as 44 pi into 10 to minus 7 Henry per meter. Calculate the force between them in kg per meter length. This is the condition. We should consider the force equation for the two parallel conductors. Therefore, F is going to be mu times I1 I2 L divided by 2 pi d. The distance what the separation is given for us, it is of 5 centimeters. I1 already given, I2 is already given. We don't, what is the L? Length of the conductor, that you have to find out. Therefore, the force, observe here one more thing. They asked in terms of kg per meter. Per meter means length should be in a division way. For that reason, force per unit meter length is given by this L is taken this side. F divided by L is going to be mu I1 I2 divided by 2 pi d. Then mu naught mu r is going to be 1 here for free space. Then you substitute for mu naught I1 I2 2 pi d, everything is given. Therefore, you are getting as 7.2 into 10 raised to minus 5 newtons per meter. That I can write as 72 micronewtons per meter. But what is the question it is asked? The force should be in terms of kg per meter. For that reason, observe here, if I want the force in kg per meter, that the basic physics that what we are going for, F divided by L is going to be, it should be divided by 9.8. This you remember. Then you will be ending as 72 into 10 raised to minus 6 divided by 9.8. Then you will be ending the converting equation in terms of kg per meter. That is going to be 7.3469 into 10 raised to minus 6 kg per meter you will be getting out. It's a simple. Okay, it's a derivation part. You can go through of this. Okay. We will continue them in the next class from question from 8.17. We'll stop here.